Particle systems. Particle systems can be used to create all sorts of different effects in computer graphics. Here's an example of a solution to the soft particle chopper task that you will have in the practice session. You can see this chopper flying up and down, and kind of this smoke or dust is flowing around in the hangar. Here's another example of some fireworks. So particle systems can also be used for some precipitation, rain, snowflakes, fireworks, sparks, all sorts of different effects like that. Particle systems can also be used to mimic different behavior. For example, here we have some fish schools that swim around while avoiding this obstacle here. Now when we talk about particles, particles have different parameters or properties, and you can add different ones. For example, one could be the transparency. So when a particle spawns, it can be fully red, but as time progresses, it can vary in transparency. Of course, it can also move, so it has some velocity, it moves to a different position, it could also change in color or do all sorts of different effects. Technically, a very good way to implement particle systems is to use an object pool. An object pool is this programming pattern where you initialize a lot of particles that are initially kind of dead or in this pool. And when you need particles, when your particle system activates, then you start taking these particles from the pool. These are already loaded in the memory, but now you're just making them alive. You're assigning them a position, some kind of a time that they are supposed to live, and maybe some velocity, and then they start moving around. When their time to live expires, then they become dead, and you return them to the pool again, making them invisible, but still keeping them in memory. This pattern and more is covered in the programming patterns in computer games course that we have in Spring. Now these particles, well, they can be 1 pixel in size, like on the fireworks and sparks on the right here, or they can have an image. So those smoke particles here are all billboard images that have their own rotations, and that makes up all of the smoke down there. Particle systems have some sort of an emitter for particles. So this emitter can be either a point where all the particles are spawning. For example, here all the particles are spawning from a point on top of this stick here. So this is kind of this sparkly stick. Or when the fireworks go out, there is this one point that is picked on the sky where all these nice particles spawn from in one go. But this emitter could also be a surface, or a volume, or a mesh. So let's say you have like a fire effect in your virtual world. So you want this campfire to emit some sparks. So there you might have a bigger area where these initial locations for sparks are randomly picked from. The very much loved and known flocking algorithm in computer graphics is called POIDS. It was developed by Craig Reynolds in 1986, and it's used to model flocking, for example, of birds or fish or some kind of small animals that like to flock. It's rumored that the name POIDS comes from how English-speaking people pronounce birds. Reynolds' paper that describes this algorithm is in SIGGRAPH from 87, and you can read about the algorithm from there as well. But in the POIDS algorithm, each particle basically follows some rules. So we have some particles, a particle system, and the first rule these particles follow is cohesion. So all of these particles tend to move towards the center of mass. So somewhere there is a center of mass of all these particles, kind of the middle point, and all of these particles try to move towards that center of mass. Of course they would try to move there in a direct line, so these curvy lines are just for illustration here. But there is another rule called separation. So all the particles try to keep some distance from other particles. For example, when two particles get too close, both of them try to move away from each other. This is similar if you think about like birds in the sky, they don't want to collide with each other while flying. And lastly, there is the alignment rule, so they all try to follow the average direction of the entire flock. Again, you can think about birds in the sky, so they try to flock together, move towards the center of mass. They don't want to collide with each other, so they keep some distance away from other birds, and the entire flock flies towards some direction. So each individual bird tries to stay with the flock and fly also to that direction. Here's an example from Scikit-learn. So this is the POIDS algorithm. All these particles are flying around, trying to be in a flock, and we can kind of change the different parameters for different rules. For example, maybe we want them to be more spread out. So all of these particles try to keep more distance from each other. Or maybe we want them to have less distance from each other, so they kind of group together more. And of course you can have all sorts of different parameters for your own rules or add your own rules to this algorithm. And you can do all sorts of cool things with these particles. For example, here's an old homework task solution that I did when I took this course. I did it in Blender, and you can see kind of this logo here that gets split up into these particles, and these particles move in this cool way. Of course, you have your own particle system task in the tools module where you can make a pretty cool smoke effect in Unreal Engine. So from this video, you should now understand particle systems, some example usages, different effects, fire, smoke, all sorts of things. You should also understand particle properties. So particles can have different properties. Position is the most obvious one, but also like velocity, transparency, and all of these can change during the particle's lifetime. We talked briefly about the object pool implementation. So when you're making a particle system, you want to allocate memory for all these thousands or 10,000s or millions of particles beforehand when your program starts, and when you need these particles, then you can just take them from the pool, directly get them from the memory where they already exist. We talked about emitters, so there's usually some kind of a location, maybe an area, maybe a volume. It could also be a mesh from where these particles spawn. We saw the Boyd's algorithm, so this is used to model flocking, for example of birds or maybe fish. And we saw the 3 default rules: cohesion, all the particles try to move towards the center of the mass; separation, they want to keep some distance away from each other; and alignment, they want to move all in the same average direction.